Hi, my name is Matt Acey, and I run the open source strategy and marketing team at AWS. And I'm happy to introduce Kai Wehner of Confluent. Kai is a technology evangelist with Confluent, a partner, an AWS partner. And Kai speaks at, or used to speak at conferences all over the world. Now he speaks from his living room to people all over the world about Apache Kafka. And he's going to talk about app modernization with Apache Kafka and the Confluent Cloud.
Hey everybody, this is Kai Wehner from Confluent. I want to talk to you today about app modernization on AWS with Apache Kafka and Confluent Cloud. That's really an exciting topic and we see it all across the globe, so really excited to talk to you about that. You can connect to me on LinkedIn or Twitter to stay in touch. Feel free to ask me any questions after the talk or join my website for more details about Apache Kafka and its ecosystem. In the first section, I want to talk to you about event streaming with Kafka and Confluent, because this is really critical to understand, because before we discuss the details about the modernization from on-premise to cloud. I assume you have realized that there is the rise of event streaming, and Apache Kafka actually was created around 10 years ago at LinkedIn. And then it was open sourced and adopted by the community and by many enterprises. Then 6 years ago, Confluent was founded to make Kafka enterprise ready and provide an ecosystem and cloud service and commercial support and all these kind of things many enterprises need. And in 2020, well, almost every big company and also small startups are using Kafka for many different use cases. So I think it's really here to stay and you should leverage that in your use cases too. That's what I want to talk today a little bit more. It's really, really important to understand what event streaming in Apache Kafka actually is. So here in this picture, you see the most important details. In the end, yes, we have producers on the left side and we have consumers on the right side. So this means Kafka provides capabilities to ingest data from data sources to data things. So it's a messaging system, right, for high volumes of data in real time with low latency of milliseconds, end to end. But Kafka is actually much more than that. So it's important to understand that it's not just a messaging system. Because the middle thing is also a storage, a distributed, highly scalable storage with high availability. And the significant difference to traditional approaches like a database is that this storage is event-based. This means that all your events are stored in guaranteed order with timestamps. And this has a few huge advantages. First of all, you decouple the producers and consumers from each other. This is very different from traditional messaging systems like JMS, and also very different from synchronous web services like REST or SOAP. And with this decoupling, you can build a flexible and scalable and agile architecture. And in addition to that, Kafka also handles the back pressure. So sometimes producers produce more data than consumers can handle. And not every consumer can be real-time. Some are near real-time or batch, or even a request response from a mobile app. And therefore, while you might have input streaming data, not everything can consume it in real time. And even some incoming data might be batch or file-based. Therefore, the heart of Kafka is really the combination of messaging and storage at scale, reliable, with backwards compatibility and rolling upgrades, so that you have zero downtime for the whole infrastructure. And this is how you can build the most critical applications and infrastructures. That's really what Kafka is. But actually, Kafka is even more. So really, if you go to the Apache website and download Kafka, you get much more than just messaging and storage. Kafka also provides Kafka Connect for data integration. This is similar, like you know it from ETL tools or an enterprise service bus where you have connectors. But the difference is that here, the connectivity and integration happens in a Kafka native way. And the same is true for Kafka Streams, the stream processing engine. With this, you can continuously process the data in real time at scale, no matter what the data source and data sink is. And this is also based on Kafka, so you can use one ecosystem to do all of that. Messaging and storage and data integration and data processing. All of that at scale in real time, highly available. And many people don't know that Kafka is that much, right? So it's pretty interesting. And so you can, as you can imagine, build many applications with that infrastructure. So Confluent pioneered that in a way. So, I mean, they're doing most of the commits still to Apache Kafka and working with the community on great new features like tiered storage and like removing Zookeeper. But today, Kafka is much, much more than what I just showed you. It's really a complete platform with many different vendors on top of that and solutions. And for example, with Confluent Cloud, you can run it across the globe in an elastic and scalable manner. That's really important for the adoption of Kafka. And therefore, I really want to talk a little bit about the use cases. As I said in the beginning, so yes, 5 to 10 years ago, many people started with Kafka as ingestion layer into Hadoop, or then a little bit later into other data lakes in the cloud, so ingest everything into AWS S3, and then run your batch analytics on top of that. And that's still a great and very valid use case, and we're seeing that a lot with Confluent Cloud and AWS S3. But there is many more use cases, as you can see here. So there's different key drivers. So one of them, of course, is increasing revenue. This means you build new business applications, new digital platforms. And this is not just the tech companies who are doing this. Like, 10 years ago, Netflix, LinkedIn, eBay, and so on, they started with that. But today, more or less every traditional company uses Kafka for new digital platforms and innovative use cases. And it really doesn't matter which industry you're in. It can be banking or insurance, or manufacturing or automotive, or telco or gaming, whatever the industry is. There's plenty of applications which leverage the innovation and architecture of Kafka for real-time event streaming at scale. However, for some other use cases, and that's more the focus of today, it's more about modernization, where you use your existing infrastructure on premise and integrate that with innovative new cloud applications. And this is where you need data integration and replication at scale. This is what I will talk about in this talk much, much more. And the third part, also mitigating risk, is a key task. So you can, for example, leverage Kafka for fraud detection and regulatory processing. So as you can see here, there's plenty of different use cases. And that's the great thing about Kafka. It's not just for one specific problem, but really for so many different use cases and architectures. But today, I want to talk about a specific use case. Modernization with hybrid architectures using Kafka and Confluent and AWS. And this is really exciting because this is what most companies have to do. Because most companies do not start greenfield in the cloud. They already have things on premise. And therefore, this is a pretty common architecture, how we see it. In some enterprises, you see some other vendors, of course, and some other databases. But in general, it is that you have on the left side on-premise in your data centers, or even closer to the edge. So in the meantime, we also work with many customers on really small edges, like outside the data center, for example, in restaurants or in retail stores. And then you do some data integration and processing at the edge or data center with Kafka. But then also you need to replicate data to the cloud in a reliable and scalable way in real time. And run Kafka there, in best case, as a fully managed service with Confluent Cloud. And therefore, the replication between these two ecosystems in data center and cloud, that's where Kafka also comes into play a lot with tools like Confluent Replicator. And so you can modernize your architecture by integrating the old world with the new world and all these AWS services you see on the right side. And of course, data integration is a key piece of that. So on the one side, we have these modern new technologies, and it's not just S3, right? So S3 is great for batch analytics and long-term storage. But you also want to integrate with other systems, and this can be AWS native services, or this can be third-party services like MongoDB Atlas on AWS, for example. But we don't only need to get the data into the cloud, but we need to get the data from somewhere. And this is also where the legacy connectors come into play. And really, there's connectors for almost everything. So with Confluent, we provide connectors to other messaging systems like IBM MQ, or even a DB2 on the mainframe. But also to many, many other systems. So you can really integrate more or less everything with Kafka. It's not just streaming data, but really it's data coming from databases, data coming from file systems, and so on. So everything can be integrated with Kafka. The key difference is that the heart of Kafka is event-based and real-time and scalable. No matter if some data sources or some data things are batch or request response, but the heart of it is event-based and real-time. And that's a significant difference for using Kafka in the middle instead of just a database or data lake. And in addition to data integration, there's another key pillar when you want to modernize your architecture, and that's stream processing. Stream processing means that you continuously process the data while the data is in motion and interesting. For many use cases, it's simply too late if you store everything into a database or data lake and process it later with a SQL query or with a web service. So think about fraud detection. You need to detect the fraud before it happened. If you want to do predictive maintenance, you need to detect the problem before the machine breaks. And if you want to upsell your customer, you need to have to do it before he left the store or the website. And that's why continuously processing data is important with stream processing. So one option is to use other stream processing frameworks. Like here on the right side, you see a few examples. This can be other open source components like Apache Spark with Spark streaming. This can be Flink or Storm. And of course, this can also be AWS native services like Kinesis. So the option is for you, and you should use the right tool for your problem. But in the end, most of them use Kafka as data integration and ingestion layer so that you get all the data at scale into the stream processing engine. And then often the result is also going back into Kafka and, like in this picture, then at the bottom into another database to process it further and do long-term storage. So there is also another option, a simplified stream processing architecture. And this is done with KSQLDB. That's a community project available for free on GitHub, which you can use to build your own stream processing applications natively with Kafka. So like Kafka Streams or Kafka Connect, it leverages Kafka under the hood. This means that you can use one single infrastructure with Kafka to build a whole stream processing pipeline for data integration, streaming ETL, and building your business applications and analytics. And that's really a huge advantage to simplify some architectures, because KSQLDB also integrates to Kafka Connect under the hood. And in addition to that, it also provides pull queries. This means while you continuously process your incoming events 24/7 in real time at scale, you can also do pull queries, for example, from a web application which uses a HTTP REST interface, so that the user of the mobile app puts a button and then it asks Kafka via REST interface to send the current status of the Kafka topic, where you do continuous stream processing on it, and send this single result back to the mobile app. And so this is really turning the database inside out, because by the foundation is a continuously streaming event, which continuously processes data, but still you can do pull queries on top of that. And that's really, I think, a great architecture. Here is one example for that. This is Bayer AG, and actually the demo here I talk about, or the architecture I talk about, is from Monsanto, which was acquired by Bayer recently. So this is exactly the problem we see at so many customers, especially companies which exist for more than 10 years. And here the problem is you have a lot of legacy technologies on premise, and it's often monolithic and not flexible, not scalable. And on the other side, you have a cloud-first strategy for new applications, for data lakes, for analytics, for machine learning, and so on. And you somehow need to connect this. And this is exactly where Kafka and Confluent come into play, to do data integration in the data center or at the edge with a self-managed Kafka cluster. And then you do the replication in real time at scale to the cloud, where you ingest it into Confluent Cloud. And from there, you integrate it with the rest of the ecosystem, which is either AWS native services or any other third-party custom application or a coded application. And then, of course, also it's a bidirectional way. So you also need to stream data back to the data center. And instead of doing a point-to-point integration between all of these services on-prem and in the cloud, Kafka is the great solution here because, again, it's scalable, it's real-time, and it's fault-tolerant. So that's exactly what you need here in the middle between data centers and cloud to modernize your architecture. So this was more the theory, so now let's get a little bit more practical and think about how to do such a modernization and cloud migration. I really want to point out that this is typically a journey. So no matter if you talk about Bayer, which we have seen, where it took years to do this architecture, or any other company, you start small and build a first use case, and then you do more and more. And over time, you can integrate on-prem with the cloud. But of course, for new application, you do it in a cloud-first strategy. And over time, you maybe can shut down some of the on-prem services or go to cloud-only mode. That's up to you and how your architecture exists, right? That's different for every different use case. In this case, I want to talk a little bit about how we've seen it from one customer in a case study where they wanted to get rid of the mainframe on-premise to save millions of dollars with that modernization of the architecture, leveraging Apache Kafka in the middle for integration. So here again, we are at the hybrid event streaming architecture. We have seen that before in the presentation, but this is really how the picture looks like in the end. But we need to get there somehow, because in the beginning, we only start on the left side with the mainframe and some other technologies running on-prem. So the typical pattern we recommend is the strangler design pattern. It's really important that such a big migration typically is not a big bang. This is a step-by-step approach, as you can see here in this picture, where we have a starting position with only old application on premises. And then we also build new applications and more new applications, and then we can migrate away and shut down old applications on-prem. And this pattern is really used especially for reduced risk. So the big bang always fails, right? That's what everybody knows or learned hardly. So here we are now in the year 0. This is our start of this project. We have a direct communication, in this case between a mainframe and an application, all of that on-premise in your data center. This is the status quo. And we want to get rid of that by modernizing the architecture and getting data into the cloud and building new applications in the cloud. Therefore, in this case, we do the data integration with the Confluent platform on-premise and with integration with the mainframe. There is plenty of options, and this is its own talk, right? So we could either do native Kafka integration with an IBM MQ connector for Kafka Connect, or we could directly connect to the DB2, or we could use a third-party tool like IIDR from IBM or any third-party vendor for direct vSAM access, whatever that is. And the same idea is true for anything else, not just for mainframes, so also for other applications on-premise. And when we have this integration, then we can replicate data to the cloud. So in this case, we actually have 2 Kafka clusters, one on-prem, and that replicates to the cloud, where Confluent Cloud is running as a serverless application. And from that, then we can build new application in the cloud with AWS services or other third-party applications. And when this is running as a first step of the integration pipeline, then over the next years, we can also build new applications which are completely decoupled. That's one of the strengths of Kafka, as I explained before, because Kafka is not just a real-time messaging layer, but also a storage layer for handling the back pressure and decoupling different services and different technologies. And that's really very important. Because still, even in the cloud, not everything will be real-time streaming. Some data lakes are batch, some mobile apps are request response. They all can use their own technologies, but they also can leverage Kafka under the hood in the middle. Because Kafka is even based in real-time in the middle, so it doesn't care if a consumer is real-time or batch or request response. So this is really a modernized architecture where we build new stuff in the cloud, but still integrate with the on-premise data. In this picture, only in one direction, but in the real world, often you also send data back to the on-premise data center and applications via Kafka. And then over time, you can get rid of the on-premise applications. Like in this case, we are replacing the mainframe application on-premise in COBOL code on the mainframe and replace it with a modern core banking application. A great example here is 10x Banking. That's one of the Confluent customers. They are having a core banking platform running on Confluent Cloud, which some banking customers use to build a new version of their banking platform. And then when they have rolled this out, then over time they can shut down their old mainframe services. In the beginning, often you don't replace everything, but it's a step-by-step approach. And even if you can only migrate and modernize 90% and still run 10% on-prem, that's still a lot of added value for your architecture over time. So with that, let's now take a look at a quick live demo which I implemented. Here you see what I want to show you. And this is actually available on the Confluent documentation. It's a demo where we run a Confluent platform on localhost, in our case for the demo on the laptop so that you can easily run it. And we have a Confluent Cloud instance in the cloud where we integrate with cloud services. And the key of the demo is really that we demonstrate how easy it is to integrate to data sources at the on-premise or the laptop in the demo, right? And replicate the data in real time to the cloud. And there we use the data for data processing in real time and also for ingestion into other data layers. Like, for example, into S3 if you want to do long-term storage there, or put other analytics services on top of that, like Athena or any other service on that. Or integrate with a third-party tool like Snowflake. And this is available in the docs, and as you can see here, this is really straightforward to set up. You can do that in 5 minutes. There's only 2 requirements. The one is that you can create a free Confluent account, and the other one is that you have a Docker so that you can run the on-prem stuff. And it's really set up in 5 minutes. What you see here now is the on-premise part. Here we are running Confluent Control Center to show you the Kafka brokers running on-premise to do data processing on-prem. In this case, we have a simulated data generation connector. This generates data continuously. And this is important for streaming data. And by the way, no matter if you use Confluent Cloud or not, this is a great open source component which you can use to generate continuous test data. So this data is sent on-premise, simulating mainframe or Oracle change data capture or whatever it is, and sending it into the Kafka broker on-prem. And then we are using Confluent Replicator to replicate this data in real time into the cloud. So this is the second part of this, right? So this is all Kafka native, using all of its features under the hood, like real-time, high availability, fault tolerance. And with this, we have the gateway between on-premise self-managed Kafka and between Confluent Cloud, the serverless solution. Of course, you could also run your own self-managed Confluent platform in the cloud, but in most cases, Confluent Cloud is easier. And here you see now the Confluent Cloud part. So this is fully managed, running in US West 2 in this case. And you can configure it like you need that. So with different SLAs. And also, in this case, you see here the throughput. It's pretty small because this is just for demo purposes. But you can scale this up like crazy. So we have customers running 10 gigabyte and more per second in one single Kafka cluster using Confluent Cloud on AWS. So you can start small in your project and scale this up without any worries about the server. Because you can take a look at the data flow like you see here, right, for the stream processing applications, in this case with KSQL. But you don't have to worry about the server side at all, because that's fully managed by Confluent. And so here you see now a few messages flowing. These messages were replicated from the on-premise data generator into Confluent Cloud. And now here we can take a look at them and inspect them, if security allows us and if they're not encrypted like in this demo case. And then we can use the data here. And in this example here now, we use KSQLDB, which is, again, one stream processing engine you can use. Also, if you use Confluent Cloud, it's fully managed, so you don't have to worry about the infrastructure. You just use elastic scaling and consumption-based pricing like for everything else from Confluent Cloud. And then you run it there to do continuous processing. Here you see the flow for the KSQL application. This is one stream which gets some of the user data and page views. In this use case, it's clickstream data, but whatever it is. We then, in this case, build a stream processing application which does filtering in real time. So in this case, we are filtering the female data. So it's pretty simple, right, for demo purposes. And in this case, we're using Avro as the value format. But in the same way, you could use, for example, JSON schema, or protobuf. And here you see the running query. And that's really important. With KSQL, the great thing is that you only write SQL queries, and you can do rapid prototyping, for example, with Python and a Jupyter notebook. But then you can deploy the same query into a KSQL server. And with Confluent Cloud, it's fully managed. If you run it by yourself, you have to run a container, for example. And then you deploy the SQL query. Nothing else, no coding. And this does continuous processing of millions of events per second, because under the hood, just like Kafka Connect or Kafka Streams, it's just Kafka native technology. And that's really the great thing of this demo here. We only use one infrastructure, all based on Kafka, to do stream processing, including messaging and storage for decoupling, but also data integration and stream processing with that. And here, last but not least, I want to show you the data integration on the cloud side. In this case, I have configured an S3 connector. So here we are sending all the data after we've processed it into an S3 object bucket, right? This is the object store of AWS, so that you can leverage all your other tools on top of that. And here you see how the data is ingested. In this case, again, it's Afro, but that's what you choose for your use case. So that's in the end what's also running in a fully managed way. That's a great thing. With Confluent Cloud, it's not just about Kafka, which is fully managed, but really the whole ecosystem, including KSQL, schema registry, all the security stuff, and also the connectors. Like you see here, you can use all the different connectors for AWS or for third-party services like MongoDB or Snowflake. You just configure them, no coding at all, and you don't have to manage them. They are serverless. You just use them, and with consumption-based pricing, you use them as much as you need. And as you can see here, it's just configuration. No matter if you use Confluent Cloud or if you use your own Kafka Connect instances somewhere, it's just configuration. You don't do any coding for the data integration. So in many cases, you don't want to write your own Java or Go code to do such integration because Kafka Connect is reliable for that. And this was the demo. I hope you realized how easy it is to use and how scalable and elastic it is. So check that out. The documentation is there. It's really straightforward. So with that, let me quickly talk about why people come to Confluent when they implement their Kafka projects on AWS. So when we're talking about cloud services, right, then we typically talk about fully managed services. So this is how a fully managed Kafka service should look like. So it's about the infrastructure, but it's also about the Kafka-specific management and scaling. And the big problem with that is that most Kafka services on the market are not really fully managed, even if the marketing says so. But many of the typical Kafka services, they provision Kafka for you, so Kafka brokers, zookeeper brokers, and then they hand it over to you. So you have to worry yourself about scaling, about error handling, about fixing bugs, about all these kind of things. And that's really what Confluent Cloud is doing. So it's a fully managed service, serverless with consumption-based pricing, where you don't have to worry about the server side at all. And that in conjunction with the additional features, for example, the fully managed connectors or schema registry, really, that's how an event streaming platform looks like. And that's why so many people work together with AWS and us to run in Confluent Cloud and integrating that both with the on-premise world and with all these other AWS and third-party services. And the other great thing why we partner so much with AWS is that we are now also certified on AWS Outposts. So this is the hardware which AWS allows you to install that in your own data center or edge cases. And with that, you can run Confluent Platform on-premise and you run Confluent Cloud in the cloud. So you have an end-to-end integration, fully supported. AWS provides the infrastructure experience and services, and Confluent provides the event streaming expertise and services and tooling. So it's a really great combination for many use cases to modernize your architecture. And also Confluent is providing other additional features. And I don't want to go into detail here, so you can check that on the website. But really, when we talk about Apache Kafka, it's a great tool, but at least if you need to scale it and run it in mission-critical workloads, it's not that easy. So additional tooling helps a lot. And here are two examples of that. So with Kafka, you need to do rebalancing to move data and partitions between brokers. And that's really hard and not really cost efficient with Apache Kafka. And so two of the things which Confluent provides on top of that is self-balancing Kafka so that you don't have to worry at all about rebalancing. And that in conjunction with tiered storage, you can offload most of the data into an object store like S3. And this is possible then again in the cloud, or if you want to self-manage it, or on Outpost in on-premise, for example. And this combination makes it really elastic and scalable and cost efficient. And also, when we talk about hybrid architectures and modernization, it's about replication and integration between different data centers and regions. And on the one side, what I have shown you today is Confluent Replicator, which we used in a demo. This is a battle-tested tool from Confluent. And now also with open source Kafka, there comes MirrorMaker 2.0. This is what you can also use in the same way. Both are based on Kafka Connect, so they leverage Kafka under the hood. Never use MirrorMaker 1. That's just a script that doesn't work well and scale well, and it's not reliable. MirrorMaker 2 is great. It's a first version, so not battle tested, but in a year or so, I think you can use that the same way. But having said that, with Confluent, we also provide you cluster linking. And cluster linking is more or less a next generation replication because with this, it's embedded into the Kafka protocol. You don't need additional tooling like Kafka Connect or MirrorMaker anymore. It's really just using the native Kafka protocol to replicate data between different regions, like if you want to replicate in real time between Confluent Cloud on AWS in US and AWS in Germany. And also the same if you want to replicate on-premise to cloud and back. And you can even use it to replicate from open source Apache Kafka to Confluent. So this is really making the architecture even more simple and efficient, and it's really a great and powerful tool. And with that, I want to say thank you. Again, if you want to stay in touch with me, please connect to me on LinkedIn and on Twitter and ask any questions you want, any feedback. And also check out my website to find out about my blogs. I blog a lot about Kafka and its ecosystem on AWS and so on. So thanks for listening, and I hope you learned a lot.